Converting from a generator to an alternator. Some of us have given up our old generator and moved ahead to an alternator. Some of us have moved from an old style alternator to a more modern and more efficient alternator. If you are the kind of classic car owner that likes to blend the classic with the modern and improved, this may be something you've thought about. Now, before we go into the details of that, there's a fundamental that we need to understand, and that's quite simply this. What's the difference between a generator and an alternator? And while there are a number of differences, we're going to talk about three of them today. And we're also going to talk about a serious similarity that's important. People have to understand this. Okay? These both make electricity. They both make the same kind of electricity. One doesn't make better electricity than the other. There are a number of people out there who believe that if I take this out of my car and I put this in, I'm going to get better electricity. Well, it's simply not the case. They both make the same thing. So then what are the differences? Well, first, even though they both make alternating current, what we call AC, they differ in how they convert that AC to what comes out, which is DC. Our cars call for DC. Also, each one is equipped with an armature and a stator, those two items. And in this one, the armature does one job, the stator does another. But in this one, the roles are reversed. So they both have an armature, they both have a stator, but those do different jobs in these two units. And lastly, generators use external voltage regulators. Alternators usually use an internal voltage regulator. So let's see if we can learn a little bit about the details that I just pointed to. First of all, I have here part of a generator. This is the case, and there are two wire windings in here. These are referred to as the stator windings. The word stator has the same root as the word statue or stationary. It means that they're fixed in place. They're not going anywhere. However, swimming around inside these is a device referred to as an armature, and she does spin. And the armature also has windings. These windings are referred to as the current generating windings. Now, when we were in school, we were taught that if we take a coil of wire and we pass a magnet back and forth through it, okay, we will create electricity inside the coil of wire. Well, also, if I put the magnet in one place and pass the coil of wire back and forth, I get the same thing. So whether the coil of wire moves or the magnets move makes no difference. The net result is the same. And also we want to note, all we have here is we have a field set of windings and a set of windings over here for generating current, and that's it. There's nothing else involved. Now at the end of this we have a series of bars. The electricity from these current generating windings comes up to these bars, and from these bars, this is where the electricity passes through these brushes, comes out this side here, and this is what goes to the car. Now, there's a couple of things that are negatives about these. First of all, generators are heavy. Okay, they also tend to be large. And they have another shortcoming. By putting all the current generating windings on the armature, that you can only spin this so fast before the spinning sensation begins to damage this. So what that means is they had to go ahead and put a larger pulley on here, which is what they did, to slow it down. Putting a larger pulley means that this is going to turn slower. When you're at your high RPMs and the engine's really spooling, what's going to happen is this is going to be able to stay within its safety range, which is great. But when the engine goes back down to idle speed again, and we're sitting in the traffic, and this isn't turning very fast for the same reason, the same pulley, this is almost valueless. They do almost nothing when they're sitting at idle speed. Now note too, I mentioned these bars here that the brushes ride on. You can see there's a space between each bar. They're actually separated from one another. If you've ever driven on a road made of concrete or a bridge made of concrete slabs, as you're driving along you can feel it, ba-boom, 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 ba-boom. The brushes are facing the exact same thing. They're bouncing along on these, and there's no way to get around that. Also, inside here we're going to produce 15, 20, 25 amps, or perhaps more current coming through here, and that's all going to go through there, and it's going to go through these brushes. What this creates is a real difficult situation for the brushes, and it means that they have to have routine maintenance. The brushes, and anybody who's had these cars for a while, have to be replaced from time to time. This part here where these bars are has to be cleaned from time to time, otherwise it simply won't be able to work. So with that going against it, the low RPMs and the maintenance, we needed something better. The next evolutionary step would have been an alternator, and we've got one right here. What made alternators the way to go, what made them possible for us, was the invention of a very small thing, a breakthrough for us, an electronic device called a diode. Diodes work beautifully and they're inexpensive. This crescent right here is referred to as a diode bank, and it has 6 diodes in it. Putting diodes in here means that we can take the stator windings, the windings that don't move, the stationary windings, and we can turn these into our current generating windings. So the current forms in these, travels through, comes out to the diode bank, and it comes out this terminal right here. This is what carries the current to the car. Making the stator windings, my current generating windings, means that I can put my light windings, my field windings, on the armature. Now imagine what that does. Having the light windings on here means this can spin very, very fast and not suffer any damage. And that's terrific. They can put a small pulley on this. So when the engine's in high RPMs, this is spinning really, really fast, but she's still within her safety zone. And what's really nice is that when I come back down to idle speed with a small pulley, this is still spinning. This can make electricity at a time when the generator simply could not. Also, having the field windings on here, which require very little electricity, we have a pair of brushes. They're located under this tab and this tab, and they reach through here to the armature, and you can see it right there. And instead of riding on bars, remember we're not using bars to do it anymore, they can ride on a pair of smooth surfaces called slip rings. The brushes ride on the rings, which doesn't beat up the brushes. The brushes have a very small amount of electricity, so the brushes don't get beat up. These last a very long time. It's not uncommon for a set of brushes in a modern car to last the entire life of the car, which is really, really cool. Now, lastly, we talked about regulators. This little domino-shaped device right here, this is the voltage regulator. You know everything that's in here. There's your voltage regulator, there's your brushes, there's your diode bank. Out here we've got our two sets of windings. That's the whole alternator. You know what's in it. Now let's assume we want to put one of these in our car. So we've got our alternator. We say, okay, I want to install an alternator in place of my generator. It's not a hard thing to do. Most people find no problems with being able to do it. The challenge for most of us is, how do we wire this upgrade? Generators had an external voltage regulator. Alternators usually have an internal voltage regulator, which makes this one nice, neat package. However, it leaves us with the old regulator and a number of wires that have to be dealt with. And if we go from an old-style alternator to a more modern one, we may be surprised to find that some of the early alternators had external voltage regulators, just like generators did. And lastly, older versions of alternators often had more wires coming out of them than the modern ones do. So with those things in mind, let's go ahead and see how we would wire one of these into our car. Okay, we have a diagram here. This will not be identical to your car, but they're all running on the same principle, so it makes no difference. All of them are going to have the generator, and we're going to see how they work. The generator is in your car. It's grounded by being bolted to the engine, so that part's easy. Generators tend to have just two wires coming out of them, a small one and a big one. The small one, if it's labeled, is usually labeled with an F. It stands for field. This is the field windings you saw in your generator a couple moments ago. The lead comes out, travels to the voltage regulator through the harness, of course, but it gets to the voltage regulator and goes to the field terminal, F to F. Easy. The D cable, the large one, this is where the electricity comes out. This is the wire, the power that carries the current out that came through the brushes and heads out to our car. And this is D, stands for dynamo, an old word for what we would call a generator today. And the label, she comes over and she goes to the D here. Again, easy. There's usually a small wire connected to the D terminal, and it comes back and comes up and goes to the light on the dashboard. This light tells you when the charging system isn't working correctly, and it also serves to prime the system when you first start the car in the morning. And we'll cover that in another video. So we've covered the D terminal, the F terminal. There's still three more in our control box. E stands for earth or ground. The last two, A and A1, they may be marked as a B, or there are other markings that they can use. They all do the same thing. What happens is the current coming out of the generator comes into the control box, and it's sent to the parts of the car that need current. One is this one over here coming around, goes to the amp meter and gets to the battery. We have to recharge our battery. The other lead comes out and goes over to the ignition switch and then splits off and also goes down to the light switch. They can do this a couple of different ways, but they're always doing the same thing. These leads also can be the same color. They're often just brown, which means that they're carrying raw current from the battery. So let's do this. Let's put this in our car. Here's our next step. What we've done is we've taken the generator out and we've put an alternator in. That part's easy. The alternator is grounded just because we've simply bolted it to the engine. That part's easy. The lead that used to be our field terminal, we're going to plug into the small terminal. If the alternator has a number of terminals, this is the smallest one. Okay? And she's usually marked IND if she's marked at all. And that stands for indicator light. Okay, so the old field wire is going to be put to use here. The old wire that used to carry the power out of the generator and off to the rest of the car, we're going to put on the biggest terminal in the alternator. This may be marked as BAT or B for battery, or it may not, but it's the big wire going to the big terminal. Small wire to the smallest terminal, big wire to the biggest terminal. That's easy. Over here, I've cut my wires. I don't need my voltage regulator anymore, so she's being relieved of duty. She's officially just cut and sitting there. So my alternator's in place. Now how am I going to wire it? Remember, I have to connect this IND terminal, this wire here, to this light, and I have to connect this thing which is bringing the power out of the alternator to the two systems that need current in my car. So let's do it. Here we are. First thing that we've done, we took the wire, the old field wire, which we connected to the IND terminal, and we're running it along, and we're going to marry it to the wire that used to be the small wire to the light that went to D over here. In other words, just going from the indicator straight to the indicator light. Perfect. Easy. 50% of our wires coming out of the alternator are taken care of. The alternator now has one more large terminal coming out. This is the large wire coming down. I need to feed my battery. I need to feed the systems in the car that want current. So we marry these together to the one lead coming out. Or if there's a few different brown leads here, we marry them all together. They all do the same thing. They're all going to need current. We marry them there. And when we've done that, that's it. The alternator can now talk to the light on the dashboard and know when it's time to turn the light on if there's a problem. The alternator makes electricity. She's internally regulated, so that's all taken care of, as she sends electricity out to the parts of the car that need electricity. Now, a couple of small things to keep in mind. Okay. Some people like the voltage regulator. They don't want to take it out of the car. It looks good in there, or at the very least, if you take it out, it leaves a hole, and we don't want that. If you'd like to leave this in your car, what you can do is you can follow the wiring harness back a few inches, open it up, and cut all your wires there. Terminate them in there. Then you can go ahead and make your connections inside the harness, like we just talked about right here, and close the harness up again. Anybody who's looking will say, there's a voltage regulator, she's got wires going into the harness, it looks perfectly fine, but it does nothing. It's just simply something to look at, an old relic. Also, alternators are polarity sensitive. Alternators run in negative ground cars. If your car is positive ground and you want to convert to an alternator, you have to convert the car to negative ground. There is no way around that. And also, when we convert the car to negative ground, anything in our car which is polarity sensitive, for example, some electronic ignition modules, they're going to have to be changed because an old positive ground electronic ignition module won't work as soon as we convert this car to negative. So what have we learned? We've learned that a generator and an alternator both make the same kind of electricity. But there are issues. The generator is heavy, the generator is large, the generator doesn't want to work at low RPMs because she's got that large pulley on her. So we learned that an alternator is compact, it's light, it's smaller, and it's a cleaner package to put into the car. We talked about, well, if we make a change from the generator to the alternator, we're going to have some wires to deal with, but as we can see, it's not an awful lot and it's pretty easy to do. So if you've decided that you want to make a jump from a generator to an alternator, or from an old alternator to a more modern one, it's easy to do. Thank you.